Hey guys, so in this video, we're going to set up a Proxmox cluster, but we're going to do it following best practices. And when I say that, I really mean using a dedicated network for the CoroSync traffic in specific. So we'll talk about CoroSync in a second here, but the goal is to split this traffic entirely so that it is only used for the cluster. That is the recommendation from the Proxmox team for cluster traffic, especially if you're using shared storage with high availability. If none of that made sense, it will make sense in a minute here. But before we get to that, I know it's going to come up, so you don't have to do this. You don't have to separate the CoroSync traffic. It will continue to work properly if you don't have a separated network the way that I'll be setting up here. However, it's not a best practice. So it'll work. You don't have to do it that way. So I'll be setting this all up on my new home server. Now, I created a video on that a few weeks ago. And what I didn't tell you guys was I actually built two of them. So the video looked like I built one. I actually built two of them. So I tried to convince myself that I needed three of them, but the reality is I don't. So I'll be setting up a 2-node Proxmox cluster, which basically means that I'll have to figure out Quorum, which is basically the health of the cluster itself. We'll talk about that in a little bit, but I'll have to maintain Quorum with a separate device. If you're setting up a Proxmox cluster and you do have 3 nodes, then great. You don't have to do a portion of what we'll be doing in this video. But what I did on those Proxmox nodes is I bought an individual network interface card that has 2 1 gigabit ports on it. And my goal in the future, if I ever add a 3rd node, would be to plug the 1st node into the 2nd into the 3rd into the 1st. And then at that point, I'll have a totally offline network purely for the cluster traffic. Now, unfortunately, because I'm only setting up a 2-node Proxmox cluster, I need a 3rd device. So I'll be using a Raspberry Pi. And I considered adding a 2nd NIC to that, but I got to the point that I'm really just complicating things. So what I'll be doing is I'll be setting up a separate VLAN purely for the Proxmox cluster traffic. So we're going to jump into it. I know that was a lot. It could potentially be confusing, but it will make more sense as we go on. So really quickly, what you'll see here is we recommend a dedicated NIC for cluster traffic, especially if you're using shared storage. So shared storage is important for high availability. If you decide to go down that path, we'll look at that as well. But this is the recommendation from Proxmox themselves. This is what we'll be doing. Okay, so this is the current VLANs that I have set up on my Unify router. So what we're going to do is we are going to create a VLAN for this Proxmox cluster. So we're going to come in here. We're going to give it the IP address of 10.3.15.1. I'm going to change this to be 315, and we're going to allow internet access, but later on, we are going to uncheck this after we install everything on our Raspberry Pi. Now, the final thing I'm going to do is create a firewall rule that blocks access from this VLAN to all local addresses. I have a video on Unify firewall rules if you're interested in seeing that. But it's basically a LAN in rule that says that if the Proxmox cluster network is attempting to get to the RFC 1918 addresses, which is every private address, it will be dropped. So the one exception to this is we're going to set the state to be new and invalid. I'll probably come at a later point and check these off as well. But if you keep these checked, we're not going to be able to SSH into the device. So basically, very high level, if you set a Unify firewall rule and you set it to block all traffic in this one direction, you're going to think in your head that you're only blocking access from the Proxmox cluster to the local addresses. But what you're actually doing is you're not allowing established or related traffic. So if you try and connect to any of those devices from a separate VLAN, let's use a trusted VLAN, for example, from a trusted VLAN to the Proxmox cluster VLAN, you're not actually going to be able to reply to that traffic from the Proxmox cluster network. So you can send traffic from the trusted VLAN, but you can't actually reply to that traffic. So that reply traffic is established and related. I have an advanced Unify firewall video that I'll be creating. Hopefully that made a little bit of sense, but if it doesn't, it'll make more sense then, I hope. So we're going to create this rule right now. And then the final thing is that on my ProMax 24 PoE, I'm just going to set these 3 ports to be for that Proxmox cluster. And then I'm going to block everything. I'm going to apply the changes, and then I'm going to go and plug those devices in. So I have my two nodes here. They are identical. I have some virtual machines on one of them and none on the other, but they match. The actual storage matches, which is important for high availability. And basically everything is standard. So the first thing we have to do is we have to actually go in and make the network changes. So we'll start on the first node and we're going to go to network. And before this video, I had figured out that this is the actual NIC I plugged in. I can always bond these in the future. I don't feel like I need to right now. So I'm going to edit this and I'm going to turn auto start on. The next thing we're going to do is we're going to create a bridge network interface. So the reason I like to do it this way is because if any of this ever changes, I'm just going to be updating the actual bridge. Everything in the cluster itself stays the same, but the actual bridge, which is referencing a separate network interface name here, that all stays the same. So everything with the cluster stays the same. However, the actual bridge ports can change in the future. So I'm going to quickly type in that specific one. I'm going to call it cluster network, and I'm going to type in an IP address of 10.3.15.10. You have to have /24 at the end here. Now you're going to want to type in a gateway address because the other bridge will have it, but it doesn't actually work because you can only have one gateway IP address per Proxmox node. If you were to try to have two, you would run into problems. So we actually don't need a gateway IP address. So as soon as we create this, everything at this point is actually good. So we're going to apply the configuration. And again, as this is applying, the VM bridge 1 is what we'll be using for our cluster network. And we're basically just going to match that on the second node. So this is our second node. I basically did the exact same thing I just did on the first one, and then we're going to apply the configuration. So at this point, we have two new Linux bridges. They are both assigned different IP addresses, 10.3.15.11 and 10.3.15.10. The next thing we're going to do is we're going to create our cluster. So I like to do it on the first one. We're going to go to data center. We're going to select cluster, and we are going to create a cluster. We're going to give it a name. And then in this cluster network, rather than using 10.2.1.10, we're going to select 10.3.15.10. So we're using the cluster network, the VM bridge 1 that we created. That's what we're using. You can add multiple for failover. I'm not going to do that. We're going to click create at this point. And at this point, our cluster has been created. So what we have to actually do is we have to join that cluster that we just created from our second node. So you can click join information here, and then we're going to copy in the information. We're going to go to our second node here. We're going to go to cluster, join cluster. We're going to paste that in. The peer address stays as 10.2.1.10. That is the actual IP address I'm using for Proxmox. I'm going to type in the root user's password, and then we're going to select that second bridge for the cluster network here. So we're going to join the PVE cluster, and if we refresh this, what you will see is that we'll have to log back in, but we have our two nodes now as part of our cluster. So we can see our virtual machines, everything looks good. Now, in order to maintain Quorum, if we come back here, what you'll see is that Quorum is okay. The problem is if we were to reboot one of these servers right now, we would not have Quorum because we would not have the total number of votes that we need. We need 3 total votes. Right now we have 2 total votes. If you have a third Proxmox node, what you would basically do is exactly what we just did, and then you'd have your third node added. For me, I'm not going to be doing that. So what I actually have to do is I have to go in and I have to set up a Raspberry Pi device. That's what I'll be using. But we're going to set it up as a QDevice, and that QDevice is only going to be used for voting. So it has to be on the exact same network that we created. So it's on the same VLAN that I created. It'll have a different IP address, but basically I have a blog article on exactly what you have to do. We're just going to come in here. We're going to actually modify it so that we can log in with the root user. You can actually specify a specific user, but then you have to go in and make sure that the user has the permissions needed to actually modify some of the system files. And since this is going to be offline, I don't care to do that. You can do that if you'd like. Then we're actually going to install the CoroSync packages that we need, and then we can move on to configuring the nodes. Okay, so up to this point, all I've done is I set up the Raspberry Pi and I gave it a static IP address of 10.3.15.20, which is on that Proxmox Cluster VLAN that we set up earlier. So basically all we need to do is come in and run a few commands. So the first thing that we have to do is we have to actually modify the SSH configuration. The reason we have to do this is because we're going to be logging in with the root user. So by default, it's going to say that it prohibits password. We're going to use the password. And this is basically just allowing us to log in with the root user using the password. So we're going to press OK. We're going to then restart the SSH service. Now, the next thing that we have to do is we have to actually install those Proxmox Quorum packages. And then the final thing we have to do is just change the password for the root user. And this is so that we can actually SSH in. Okay, so now that that's done, what we have to do is run a few commands on our actual nodes. So we're going to access the shell, and we basically have to install this package on each node so that it's able to use the QDevice. So we're going to do that. We're going to install it. And as soon as we do it on the first, we're going to do the same thing on the second. Okay, so now that we installed the packages, it should be as simple as running this command. So basically, we're adding the QDevice at this specific IP address. This is the IP address of our Raspberry Pi. We're going to press enter. It's going to ask us if we want to connect in. We have to type in the password of the Raspberry Pi, and then it should do what it has to do. And if we run the command pvecm nodes, you should see the QDevice here. And if you do the same on the second node, you should see the QDevice there as well. So at this point, what I want to show you is if we come into high availability, at this point, you'll see that Quorum is okay. And if you go to cluster, you're going to see that we have 2 nodes, which is correct, but we technically have 3 votes. So if we run the pvecm status command, what you'll see is that these are the 3 nodes that we have. So to show you that this will still work, we're going to shut down the second node that we have, and Quorum should maintain throughout this. So in the HA tab here, we have Quorum as okay. And with that node offline, everything stayed as is. Now, if you didn't set it up this way with that third vote, Quorum would actually be bad at this point and our whole cluster would be shot. So everything is working as expected at this point. Okay, so with everything back online, there's a few things that I want to show you for the cluster. What we can actually do is we can come in here and we can migrate virtual machines. So I will quickly migrate this from the first node to the second node. And what you'll see is in a second here, it will migrate it. And what you will see is that now this virtual machine will start up on the second node. Everything is good. So you can migrate virtual machines from one node to another. Next is going to be actual high availability. So high availability is going to be dependent on basically what option you use. So you can create a virtual machine with shared storage. So what you'll see is I have shared storage here, the UNAS Pro, and I can come in and create a new virtual machine. And when I select the actual disk, what I can do is select that UNAS Pro. That's an example of what shared storage is. If you set up shared storage and you want high availability set up, you would do it the same way as any other option. Another way of doing it, if you don't want to use shared storage, is by setting up something called replication. So we're going to set up replication, and this is what I'm mainly going to use at this point, but I'm going to set up replication for this surveillance VM. And I want it to replicate from PVE 01 to PVE 02, and I'm going to do every 30 minutes. So when I create this task here, what you will see is that it's going to be in a pending state. And then at some point over the next few minutes, it's going to replicate that VM from this first node here to this second node. Now, the replication doesn't actually configure high availability, and neither does the shared storage. We have to go in and configure high availability after that. So after this syncs, high availability will work, but I'll quickly talk through how that will work. In high availability, we can come to add, and we can add our specific resource. Now, basically, we just want this to stay started. So the request state will stay as started, and if it notices that it's not started, it will start it up on a separate node. Now, there's a lot that you can do here, so I'm going to add this here. And what this basically says is that if for whatever reason, this virtual machine is not started, start it up on one of the nodes. Now, there's other things that you could do to kind of refine this a little. So these are the exact same thing in terms of hardware. So I have no real reason to actually modify anything further, but you can come in here and create groups. So let's say you wanted to create a group, if you had 3 nodes and you only wanted the group to consist of 2 nodes, you could select both of the nodes, you can give it an actual name, and then when you go in and configure high availability, you can select that group. This is very, very powerful if you have potentially different hardware on some of your nodes, etc. But the idea is that you can set up different groups and then you could have different high availability rules based on those specific groups. Now, the final thing I want to say is off camera, VM data was not added to the actual second node. So in order to do that, I went to storage VM data, I edited this, and I just selected it from here. It was only selected for PVE01. You have to select PVE02 as well. And that's why in the last video, I set up storage with the exact same name, because if it didn't have the same name, you would run into problems. But at this point, we have 2 nodes. We're using a Raspberry Pi for the 3rd vote. We set up high availability. And at this point, if I actually come in and I shut down this PVE01, it will migrate to this PVE02. And the reason it will is because we set up high availability for that specific virtual machine and the state has to say as started. So I'll be using replication for the foreseeable future at this point. So I'm basically just going to set up replication for all of these. Not ideal, shared storage would be better, but these are my main ones and this is what I really need it on. Okay, so it's been a few days and I thought I would show you how I set everything up. It's very basic. This is just the beginning of this server, but everything is set up right now and I wanted to quickly show you how I did it. So right now, the virtual machines that you see are set up on the primary device that I want them to run on. So these 3 will run on PVE01, these 2 will run on PVE02, and that's assuming both nodes are up. So what you'll see is I configured 2 high availability groups. So I have PVE01 primary and PVE02 primary. If you double click into this, you will see the priority set up here. So the highest priority is where the virtual machine will run. So in this case, you'll see that PVE01 is set as 2, which basically means that any of the high availability virtual machines that are configured with this group should be running on PVE01. Now you can set up things like restricted. If I wanted to restrict certain virtual machines to only PVE01, I could do that as well. But overall, I don't need any of that. The other thing you could do is configure no failback. So if the virtual machine goes down, meaning PVE01 goes down, the virtual machines would not fail back after they migrated to PVE02. So they'd run on PVE02. Once PVE01 came back, they would not move back. With this disabled, if PVE01 goes offline, they will migrate to PVE02. And then as soon as PVE01 comes back online, they will go back to PVE01. I know, a little confusing, but PVE02 is basically just the opposite, has a higher priority. They're configured the exact same way. So now inside of the actual high availability, I configured all of these. So what you'll see is I have the state set as started. So that means that the cluster views them as must being started. If they're not started, it will attempt to start them on one of the nodes. And then from there, the only thing I did is set the group. So as you could see, some of them are designed to run on PVE01 and some of them are designed to run on PVE02. So that's the high availability section. Now, again, I'm not using shared storage right now. Maybe in the future. I tried to convince myself to set up a Ceph cluster when I wanted to go with 3, but didn't succeed in that. So we are using replication. And basically, I set up the replication to run at minimum once a day. So from a replication standpoint, things are pretty basic. I replicate these 2 virtual machines once a day. I replicate this surveillance virtual machine every 10 minutes because this changes a lot. So that replicates every 10 minutes. And then these 2 are just every few hours. So this is every 2 hours and this is every 6 hours. Now, in terms of the replication, because we're using ZFS, you could see how fast it goes. After that initial sync is done, it took a total of 4.8 seconds to replicate that virtual machine. So very, very, very fast. Not something I really have to worry about. But overall, that's the basic setup. This is about as basic as this setup will ever be, but this is the absolute bare bones right now, and I will continue to grow this. So overall, very powerful that you could use high availability. Very powerful if you just set up a cluster without high availability. But if your goal is to set up high availability, especially if you're going to use shared storage, it is a recommendation to use a separate network. Not that you have to, but that is the recommendation. So I know there was a lot here. That article, I will be updating it. I noticed a few things as I was going through it that need to be changed. So that article, I'll leave a link to it in the description if you do want to set up the QDevice. And that will basically allow you to set up a Proxmox cluster with a Raspberry Pi as a third vote. Or realistically, it doesn't have to be a Raspberry Pi, but any device as a third vote. So if you have any questions, feel free to leave them in the comments. But if you made it this far, thank you very much for watching. I will see you guys next time.